All right, guys, back at it. From what I've heard, it looks like this is our last week of sort of instruction, so we'll finish up this topic of trigonometric equations this week, and that'll wrap it up for the year. Okay, so let's see this guy. I know when I first look at it, I'm thinking, well, this has got to be real similar to one we looked at last week where we had cosine to the fourth and cosine squared, as well as I think you had one on the quiz that's due tonight with sine to the fourth and sine squared. So I'm thinking put it in standard form and then see if we can factor it. So I'm going to take everything on the right side and move it over to the left. Okay, so I'm going to get tangent to the fourth of x. That would be minus 2 tangent squared of x plus 1 equals 0. And boy, that certainly looks like a perfect square trinomial. Okay, yes, it most certainly is. So this guy is going to factor into the square of tangent squared of x minus 1. Okay, and you could check that. You know, if we square this, we get tangent to the fourth. Then 2 times tangent times 1 is 2 tangent squared, and obviously a minus, and 1 squared is 1. So it is a perfect square trinomial. Okay, so if that's the case, we are going to get tangent squared of x minus 1 must be equal to 0. Okay, so that takes us to tangent squared of x must equal 1, and taking the square root of both sides, tangent of x would be the positive or negative square root of 1, which is either plus or minus 1. Okay, so we take a look there. Okay, so I've got tangent of x equals 1, and tangent of x equals negative 1. All right, so remember, we go to our unit circle. And we say, okay, well, if tangent is 1, that means the x coordinate and the y coordinate have to be exactly the same. So that would happen at pi over 4 and 5 pi over 4. Okay, you'd get, y coordinate over x coordinate because it's sine over cosine. Okay, so that happens at pi over 4 and 5 pi over 4. Okay, let's see, this is x equals pi over 4 and 5 pi over 4. Then if tangent is going to be negative 1, that means the x and y coordinates have to be opposites of each other. Okay, so when we go y over x, we get negative 1. So that's going to happen at 3 pi over 4 and 7 pi over 4, right here and right here. Okay, so that gives us x equals 3 pi over 4 and 7 pi over 4. Okay, so we have our solutions on 0 to 2 pi. We've got 4 of them. X equals pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4. And then if we want to go on the set of real numbers, just like we were doing last week. Okay, so x equals pi over 4 plus 2n pi, and 5 pi over 4 plus 2n pi, and 3 pi over 4 plus 2n pi, and 7 pi over 4 plus 2n pi, where obviously, once again, n is any integer. Okay, so that guy's done. All right, no biggie. Let's see this guy. Okay, this guy's looking a little bit different. Here's I got cosine and sine in the same equation. Okay. Now, if we did have like cosine squared, I could substitute in 1 minus sine squared to get everything to be sine, but we don't have that. Same thing if, sine was sine squared, I could substitute in 1 minus cosine squared to get everything in terms of cosine, but I don't have that. But I'm looking at these two guys and I'm thinking, well, they do have a common factor. So why not get everything on the same side, put it in some sort of standard form, and then factor out a GCF and see what happens. So I'm gonna bring this guy over like this. Okay, so we're gonna have cosine x, sine x minus 3 cosine x equals 0. Okay, so if I factor out a cosine of x as a GCF, I'll be left with sine of x minus 3 inside. Okay, so I can use my zero product property. Well, if this times this is equal to 0, then either that's equal to 0 or that's equal to 0, one or the other. Okay, so I get cosine of x equals 0, and I get sine of x minus 3 equals 0. Okay, so this guy right here, when its cosine equals 0, well, cosine is our x coordinate. Okay, so that's going to happen at pi over 2 and 3 pi over 2. Cosine will be 0. Pi over 2 and 3 pi over 2. Okay, so right here we get pi over 2, 3 pi over 2. Right here, let's see, I add 3 to both sides. Sine of x equals 3, and that is no solution. Okay, remember, okay, the range, okay, of sine goes from -1 to +1, okay? So there's no way that the sine could ever be equal to 3 because 3 is not in that range. So we get no solution here. That's impossible. Sine of x could never be equal to 3. Okay, so I just have these guys. Okay, so on 0 to 2 pi, I have 2 solutions. X equals pi over 2 and 3 pi over 2. And if we go to the set of all real numbers, I get x equals pi over 2 plus 2n pi. Okay, and x equals 3 pi over 2 plus 2n pi, where n obviously, once again, is an integer. Okay, so we're in good shape. Okay, so that guy's down. Let's try another one. Boy, this guy looks really similar to the last one we did. Okay, so I'm thinking, all right, well, why not try the same plan of attack? Let's bring this guy over and let's see what happens. Okay, so I move that guy over. I've got 2 sine x cosine x minus radical 2 cosine x equals 0. So I've got a GCF of cosine of x, so let's pull that guy out. Okay, so cosine x, and I'll be left with 2 sine x minus radical 2 equals 0. Okay, so let's see, that'll give me the cosine of x equals 0, and that'll give me 2 sine of x minus radical 2 equals 0. Okay, so this guy we just solved on the last one. Remember, that happens at pi over 2 and at 3 pi over 2. Okay, so right here we get x equals pi over 2 and 3 pi over 2. Okay, this guy, let's see. I would have to add radical 2 and then divide by 2. So the sine of x would be equal to radical 2 over 2. Let's see. Where does that happen? Notice sine of x is radical 2 over 2. So that means our y-coordinate has to be radical 2 over 2. So that will happen at pi over 4 right here and at 3 pi over 4. Okay. So pi over 4 and 3 pi over 4. Okay, so let's see. Pi over 4 and 3 pi over 4. Okay. So let's see, on 0 to 2 pi. Okay, I have pi over 2, 3 pi over 2, pi over 4, and 3 pi over 4. Okay, let's see, the set of real numbers. I know this gets monotonous, doesn't it? Pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi, pi over 4 plus 2n pi, and 3 pi over 4 plus 2n pi, where n is an integer. And there we go. We're good on that guy. Okay, so far so good. Got one more problem to do. Let's see. Okay. Well, you know, I see that sine squared. I'm saying, okay, do I want to substitute in 1 minus cosine squared there? I don't think that's going to help us, because then we still have tangent and cosine both in the same equation. But notice that this guy and this guy do have a common factor of tangent. So why not do the same thing? Why not put it in some sort of standard form and factor out a GCF and see what happens? Okay, so I'll bring this guy over. Okay, so I'm going to get tangent x sine squared x minus 3 tangent of x. Okay, equals 0. I'm sorry, equals 0. So we factor out tangent of x, and I am left with sine squared x minus 3 equals 0. Okay, so that would mean either the tangent of x equals 0 or sine squared x minus 3 equals 0. Okay, so let's see. When will tangent be 0? All right, now remember, tangent is sine x over cosine x. So for it to be equal to 0, we got to get 0 up above and some non-zero number down below. Okay, so when is the sine equal to 0 but the cosine is not? So we go to the unit circle. And we say, okay, when is sine 0? Remember, sine is your y-coordinate, so that happens at 0 and pi. Okay, so the tangent will be 0, okay, at 0 or 2 pi. You could use 2 pi if you wanted to, but I'll use 0, 0 and pi. Okay, so that happens at x equals 0 and x equals pi radians. Okay, so over here, okay, so we'd add 3 to both sides. Sine squared x equals 3, and then we take the square root of both sides, and obviously we got 2 square roots, so sine of x would be equal to plus or minus radical 3, and once again, we got a problem here, because the range of sine goes from -1 to +1, and radical 3 in absolute value is greater than 1. Okay, so we got no solution here. Okay, so I only got 2 solutions. Okay, so let's see. On 0 to 2 pi, okay, we got x equals 0 and pi. Okay, let's see, on the set of real numbers, I've got x equals 0 plus 2n pi, and x equals pi plus 2n pi, where n is an integer. Now, there's nothing wrong with this, but we could do this a little bit better, because you figure this is all the even multiples of pi, and that's all the odd multiples of pi. So going together, we have every single multiple of pi. So we could just say x equals n pi, where n is an integer. Okay, this would be the best way to do it, okay, right here. But this is still okay. Okay, there's nothing wrong with that. Okay, so just 2 different ways, but obviously this guy would be the best way to do it, but this would still be correct. Okay, that wraps it up for today. Don't forget about the quiz. Get it turned in today. I'll start grading those things tomorrow and get them back to you shortly. Miss you guys.